Okay, so the last of our little identities is just a nice little way of solving a cos x plus sine x. Now, invariably, when we have in methods a cos x plus sine x, it's normally cos x plus sine x equals 0. So you can take your cos x across, or sorry, your sine x across, divide both sides by cos x, and you end up with a tan x equals. Okay, and that's fine. But what happens if we have a cos x plus b sine x is equal to something, equal to 1? Okay, it's a bit more problematic in terms of solving. All right, so whilst we don't have to remember the proof of it, okay, what we're saying that a cos x plus b sine x can be written as r cos x minus alpha. All right, and a cos x plus b sine x could also be written as r sine x plus beta. And so where the other values come from, the r value, as you expect, the square root of a squared plus b squared. So it's got to do with the radius, okay, and that right angle triangle that we create. And the alpha sign comes from solving the angle equal to a on r and b on r. So cos of the alpha equals a on r, sine of alpha equals b on r. And the angle that you pick has got to satisfy both those conditions. All right, so look, I could just very briefly, if I talk about the proof, if r is equal to the square root of a squared plus b squared, that means the point P, if we put P as a point on the unit circle, well, that distance of r there, is just the square root of a on r plus b on r all squared. So it's y2 minus y1 all squared plus x2 minus x1 all squared. So that's what we've done there, use the distance formula, which means I get the distance of a squared on r squared plus b squared on r squared, square both sides. So the distance OP squared is the same as a squared on r squared plus b on squared on r squared. All right. Now, and obviously since r squared is the same, or r is equal to the square root of a squared plus b squared, r squared is a squared plus b squared. So OP all squared is the same as a squared over a squared plus b squared over a squared plus b squared. Okay, so from our unit circle, okay, I know that x is equal to cos theta and y is equal to sine theta because r is equal to 1. So x is equal to r cos theta and y is equal to r sine theta, but the radius is 1, which means cos theta is a on r and sine theta is b on r. So if I consider the expression a cos x plus b sine x, if I multiply by r, which means then I divide everything by r to keep equality, I get r outside of a on r cos x plus b on r sine x. A on r, okay, well, that's the same as cos theta, and b on r is the same as sine theta. So I get a cos theta cos x plus sine theta sine x, which is my compound angle rule for cos of x minus theta. So look, you'll never be asked about the proof. It's there in case you're interested in the proof. It makes more sense if we go on and do an example. So if I want to express cos x minus root 3 sine x in the form r cos x minus alpha, and hence find the range of the function f with the rule. Okay, so there's my expression. All right, so the a value is a 1 cos x minus root 3 sine x. So the a value is 1, the b value is negative root 3. R is equal to the square root of each of those squared, so r is equal to 2. So to work out the angle, I need to solve cos theta equal to a over r, which is 1 on 2, and sine theta equal to b over r, which is negative root 3 on 2. So the angle that satisfies both of those conditions is minus pi on 3. So we know the theta, we know the r. So I know that in fact, this expression is equal to r cos x minus alpha. R was equal to 2, and alpha was minus pi on 3. So we get 2 cos x plus pi on 3. So that's an equivalent expression to cos x minus root 3 sine x, all right? So in terms of maximum minimum, well, clearly the maximum value of cosine is 1, the minimum is -1. So with a 2 at the front, the maximum is 2 and the minimum is -2, all right? So this is where it becomes a little bit useful. If I want to solve cos x minus root 3 sine x equal to 1, I can't do it using my methods approaches. All right, so from the top, we can soon see that we can rewrite the left-hand side as 2 cos of x plus pi on 3. So if I solve that, divide by 2, I get a half. So x plus pi on 3 is negative pi on 3, etc., etc. Subtract pi on 3 from all sides, eliminate the values that aren't relevant, and I get 0, 4 pi on 3, and 2 pi is my solutions. All right, so again, these last two exercises, really making sure you've got your formula sheet with you, okay?